In this video, we discuss learning outcome number 1 from lesson 4.2. My goals for you are these. I want you to be able to distinguish between simple and compound events, and then I want you to be able to describe how these events are related to the addition and multiplication rules for computing probabilities that we'll be discussing in this section. So let's look at the definitions. Simple events have already been defined. We defined them in lesson 4.1. We said that simple events are outcomes or specific events that cannot be further broken down into simpler components. A compound event is any event that's not simple. This is an event that combines two or more simple events. So I've already seen some examples of this. We're going to revisit those examples. Now we're going to use our new terminology, which is that an event combining two or more simple events is called a compound event. Now, the addition and multiplication rules that we'll be studying in this lesson allow us to find probabilities of compound events. In lesson 4.1, we could just use those 4 approaches to finding probability, to compute the probability of a simple event. Now we want probabilities of compound events, and the addition and multiplication rules are appropriate here. So let's revisit that idea of a compound event by revisiting an old example from lesson 4.1. Let's say we've got some events and we want to classify them as simple or compound. If you have 3 births, and we're talking about 3 consecutive births, so there are no triplets here, there are no twins, the result of 2 girls followed by a boy is called a simple event because there's only one way to get 2 girls followed by a boy. The oldest daughter or the oldest child would be a girl, the second oldest child would be a girl, and then the final child is a boy. Now, if you have 3 births, the result of 2 girls and a boy could happen in a number of different ways. It could actually happen in 3 ways. You could have 2 girls and a boy. So an oldest sister, a middle sister, and then a youngest son. Or you could have a boy and 2 girls. So you could have an oldest son, and you could have 2 younger sisters. Or you could have an oldest daughter, then a son, and then another daughter. So there are 3 different ways that we can get 2 girls and a boy out of 3 births. So that means that this is not a simple event, but a compound event. We also looked at this example. If you're rolling a single die, that's like one of a pair of dice. The outcome of rolling a 5 is a simple event. If I have a single die and I roll it, the possibilities are 1, 2, 3, 4, 5, 6. There's only one way to roll a 5, so that's a simple event. But the outcome of rolling an even number, well, that could happen in a number of different ways. You could roll a 2, and that would count. You could roll a 4, that would be an even number. You could roll a 6, that would be an even number. So the outcome of rolling an even number could happen in one of these 3 ways. That means that the event of rolling an even number is not a simple event, but a compound event. Now here's some notation related to compound events. The probability of A or B is denoted this way. This denotes the probability that A occurs, or event B occurs, or both occur at the same time as an outcome in a single trial in a given procedure. So this can be represented by this Venn diagram. If this circle represents all of the ways that event A can occur, and this circle represents all of the ways that event B can occur, the probability that A or B occurs, so that's the probability that A occurs, or the probability that B occurs, or the probability that both occur, comes from adding up all of the ways that the probability, or all of the ways, that A can occur, and then adding up all of the ways that B can occur. We want all of the members of this set and this set divided by the total number of outcomes. We're going to use the addition rule. We're going to talk more about that addition rule in the next lesson. Now, this is for probability of A or B. Now, the probability of A and B denotes the probability that both A and B occur at the same time as an outcome in a single trial. Here, we're looking for the events where that count as part of event A and count as part of event B. So we're looking for the events, or the probability of the events where we have that overlap. So the events that are in this overlap in our Venn diagram, those are the events where A and B occur at the same time. So we would take that number of events that occur in A and B at the same time, and we divide by the total number of possible outcomes, and that's going to get us the probability that A and B occur at the same time. We will use the multiplication rule to find probabilities of A and B later this semester. So that's it for our discussion of compound events. We'll talk about learning outcome number 2 in the next video.